Hello again, it's Dave Giles here for the next lesson of Cambridge International Education, IGCSE Physics, Unit P1, Motion, Force and Energy. And today we're looking at distance and displacement time graphs. So I put a little starter question on here for us. I want you to plot a distance time graph using the information below. Car travels 3 kilometers in the first 2 minutes of its journey. So in the first 3 minutes, it travels the first 2 minutes, it travels 3 kilometers. So we can put that on. The car then travels another 3 kilometers in the next 5 minutes. So that takes up to 7 minutes on here. Another 3 kilometers takes us up to 6. And that's 3 minutes of the journey. The car travels another 1 kilometer. Okay. I'll put a little extension question on. What is the average speed of the car? Now, you don't have to work out each individual speed. You just look at the total distance and divide by the total time. So 7 kilometers, 10 minutes, 0.7 kilometers per minute. Now you should convert it to meters per second or kilometers per hour, but we'll leave it as 0.7 kilometers per minute for now. Now, normally when we plot a graph, I say don't do a dot-to-dot. A distance or displacement time graph is probably the one of a few exceptions where you do each individual plot, each individual point, then join them up. So today, when you describe motion from a distance displacement time graph, calculated velocity from a displacement time graph, applied mathematical knowledge to determine acceleration. Okay, so the first objective, interpreting a displacement time graph. So this shows the object moving away from the start point at a constant speed. Here we've got a stationary object, and this shows the object back at the start point at a constant speed. So it's actually turned around and gone back to where it initially came from. Notice this is displacement on the side. So the slope of the graph is called the gradient. The gradient of a line and a distance time graph equals the speed or velocity from a displacement time graph. The steeper the gradient, the faster an object is moving. It is difficult to calculate the gradient of a realistic graph because the line is curved, although we will actually look at how you do that a little bit later on. However, for now, we'll simplify by using straight lines. So what's the speed of the object between points A and B? So the gradient is change in y divided by change in x, or you can say the object has moved a distance of 60 meters, 70 minus 10. It took 3 seconds to move this distance, so that's the change in x. Speed is distance over time, or you can say gradient is change in y divided by change in x. Either way, it's 60 divided by 3, which gives me 20 meters per second. Okay, and going back to the curves we mentioned earlier, if you've got a curved graph like this, that means the velocity is changing. So that means we've got acceleration. So at any point on a graph, the velocity equals the gradient at that point. For a curved displacement time graph, to determine the velocity at any time, you must take a tangent. So a tangent is where you follow the curve at that point. You do a line parallel to the curve at that exact point. A curve in a displacement time graph means an object is accelerating or decelerating. So here you can see it's going faster, then it's getting less and less steep, the gradient. So this here is decelerating in this example. So quick question, what does the graph show below? This is, now D is probably a term you shouldn't use, V would be better. But here we have got constant velocity. Next, the distance isn't changing, so it's stationary. Here it's stationary as well. Here we can see the gradient is getting steeper, so it's accelerating, and here the gradient is getting less steep, so it is decelerating. So let's have a look at some paper 2 multiple choice questions. Now, I'm actually going to start us off with paper 1 question. So this is the core paper. The graph shows how how the distance traveled by a vehicle changes with time. Which row describes the speed of the vehicle in each of the graphs? So from P to Q, we've got constant speed. So we know it's either A or B. Q to R, the speed is 0. Okay, so it could still be either A or B. And from R to S, it is a constant speed as well. So the answer is A. The diagram shows distant time graph for objects. Which graph represents an object moving with an increasing speed? So the only one with an increasing speed, these are constant speeds. Well, that's stationary, that's constant speed. This is decelerating, and this one's accelerating, which is increasing speed, so it's D. And which one represents a graph that is moving at a constant speed? The keyword being moving. Okay, so you can say this here is constant, but it's a constant of 0, so it's not moving, so the answer is therefore D. Although it is, it would appear to be going back to where it came from, it is a constant speed. For objects moving on a straight line, the distance of an object from a fixed point on the line is plotted against the time for each object. Which object is decelerating? So it's the one with the decreasing gradient. So that would be C. The distance time graph for a student walking across a park. What's the student's average speed walking across the park? Well, it's just total distance, 50 meters divided by time for 20 seconds. So 50 divided by 20 is 2.5 meters per second. And the last one, which distance time graph represents an object as moving with constant speed? So it's like changing speed. The only one where the speed is changing is the one where you've got a non-constant gradient, so that is D. Okay. The next lesson will be on velocity and time graphs. It'll be a little while till I upload, but when I do, I will post a link down in the description below. Thank you very much, everyone, and I will see you later. Bye-bye.